awkward. All right, so my first thought was we could go over maybe just like any part of this. I'll give you papers to say. Any part of this that you feel a little bit rusty on. Isn't this school fancy?
Yes.
So I thought we could maybe talk about the problem first, so that if you're looking at the problem, like I literally don't remember any of this, and I'm just going to sit here for 15 minutes and write nothing but doodle maybe. I thought we could talk about the question first, and so then you would have an idea of maybe the math involved, and then we can actually spend some time trying the question. Okay? So go ahead and take a moment. We're going to read it. I don't really want to do the read out loud thing because I'm not an English teacher. So go ahead and read it silently to yourself. Yeah, so this is FRQ2. Anyone know about the numbers? 1 and 2 are always active. 3 through 6 are not, okay? So this is 2, that means this is calculator active, so if you have a calculator, get it out. If you don't have a calculator, I do have 6. So first come, first serve. Whoever can run up here the fastest. Andy, you have to get up. Are your legs broken? You're a healthy dude.
Then look for my calculator.
Oh, look at that. Yeah, I got one more calculator. One more. Okay. So this is calculator active. So since it's calculator active, that means if you're finding an integral or if you're finding a derivative, please don't do it by hand. Then you're going to potentially make unnecessary algebraic mistakes. Also, since it's calculator active, they're going to give you harder things to do the derivative or integral of. So doing it by hand would be unnecessarily difficult. Okay, so we have 2 different situations here, and make sure you properly label them. So this is the rate out, because this is the customers removing the bananas. It would be very unfortunate to get these mixed up. So rate out. And then this one, after the store has been open for 3 hours, maybe underline that. So this is not at t equals 0. This would be at 3 hours in. This is where they start to replenish the bananas. So it's good to make sure you don't get those mixed up, especially since they do out as the first equation, in as the second equation. All right. For part A, when it says how many pounds of bananas are removed from the display table during the first 2 hours the store is open, somebody without giving me the actual answer, can you tell me what mathematical process we would probably use for that? Say again? Not f of t. You're going to be adding things up. What in calculus? Integral. Okay, so your hint for part A is integral. Okay. Part B says f prime of 7. So what does that mean? Derivative. And then using correct units. So be careful about that one. And it says explain the meaning of that in the context of the problem. I chose this problem specifically because of part B. This is a common thing for them to ask you to do, is not only to have the units, but to explain it in the context of the problem. Okay? So be very careful about that. Make sure your information in your answer does not talk about average rate of change, because derivatives are instantaneous rate of change. So you're going to say, at that moment, this is what the rate of change is. Okay? Part C. Is the number of pounds of bananas on display increasing or decreasing? So typically, how do we check to see if something is increasing or decreasing? Derivative. Derivative is positive or negative, okay? You have to take both of these into account, right? Your in versus out. So think about how you're going to be doing that, how you're going to use both of them, right? Okay. All right, and then part D, how many pounds of bananas are on the display table at the time t equals 8? So again, we're thinking about adding stuff up, right? So what are we going to have to use for part D? An integral, okay? So I'm going to give you some time to go ahead and try that problem. You have your hints. Do the best you can, okay? Do not open your other packets yet. That would be cheating. I will give you an F. Get it? It's funny because I can't. Okay. So I'm going to put my answers up here like the way I wrote it out. You are also welcome to get your rubric packet out and look at the rubric for this one. So I believe it's on page 2. So, so for the first one, because you're looking at how many pounds of bananas are being removed from the display, that means that we're doing the integral and we're using f of t because that's where we had the bananas being removed. So our integral is from 0 to 2 because it says 2 hours. And so 20.051 pounds of bananas have been removed. So on this one little trick for the FRQs to be able to get your points is you do have to write the integral, and if you look at the rubric, you can see that it gives you 2 points for this problem, 1 point for the integral, 1 point for the answer. One little trick for getting the point for your integral is to just say f of t dt. The reason that could be beneficial is if you make a little mistake when you write this down, you won't get the point for it. Like if you did t over 100 and just missed the cubed, then you would not get that integral point. So if you write the integral of f of t dt, then you're less likely to make a little mistake writing it. It's just a little trick. I don't like doing that because I plug it in directly from what's on my paper, but that is something you can do. Yes?
How many decimal codes do you typically want?
Always 3. So the way the AP exam is graded, you have to have 3. You can have more than 3. You cannot have less than 3. If you have less than 3, automatically you're wrong. Okay? Yeah.
In terms of margin of error, like my calculator says 20.000894. So it's like very similar to that answer.
How did you plug it in? Did you do the math 9?
No, I did the on the graph.
On the graph? Okay. I don't know. To me, that's where you have. So your option is you can have. Well, this one wouldn't be have a rounding error, but 051. If it's not 051, they will not give you the point for it.
Okay.
So the other option, this is like there's like true rounding and then there's truncated rounding. Truncated means you just cut the number off and you don't care what's after it.
Yeah.
So if it's a 5 or above, you don't care about rounding up, you just leave it. This one, it doesn't really make a difference because of the rounding. But if you're to do this without doing it on the graphing, and I can come check yours specifically to see if there was maybe a bit or something. But if you do math 9 and then 0 to 2, this might be an easier way to do the problem so that you don't have to get the graph and find the window and do that every single time. So if it's not imperative for you to look at the picture of the graph, then this is probably the better way to type something in. So at this point, we're just doing 10 plus 0.8x sine x to the third divided by 100. So with this one, truncated rounding versus regular rounding would give you the same answer. Does that make sense? Okay. All right. Part B, so you get 1 point for the value and then 1 point for the context that you said. So negative 8.120, 7 hours after the store opened, so we're answering that in context of the problem, that's a 7. The number of pounds of bananas being removed from the display is decreasing, that's what the negative means. So the number of bananas is decreasing by 8.120 pounds per hour, because the equation said pounds per hour, and then we are adding a rate on top of a rate. Yes? Per hour squared, yes. Yes.
Could you put it t equals 7, or could you not?
I think you can put at time t equals 7. That's fine.
I found out what my problem was. This was not reset, and it's degrees.
There you go. There you go. Yes.
I was like, that's distressing.
Yes. Well, one thing, so my class looked this up because I was like, why do derivatives not work in degrees? And that your derivative rules that you've learned, like the derivative of sinus, cos, and all that, those are all based on radians. There are different rules for degrees. So if you're ever wondering if it should be radians or degrees, always, always, always radians, because you don't know how to do degrees, unless your teacher taught it to you.
Instead of saying decreases, would you say loses? Or would they want specifically?
Well, they're not, you're not saying, so the idea behind this is that bananas are being removed from a display, right? And it's almost like at the beginning the store is open, everybody's grabbing bananas, and then as time goes on, less and less, so bananas are still being removed, but not as many of them. So if you say that you're losing bananas, I don't know if you're getting that same idea across. Does that make sense? Okay. All right, so for part C, for this one to find the difference between the two, or how is it actually phrased? Is the number of bananas on the table display increasing or decreasing? So g of 5 minus f of 5. And again, I'm showing that work. So, because if you look at the rubric, you can see it says considers f of 5 and g of 5. So just considering those, not even writing it correctly, but just considering those gets you a point, which is why even if you don't know how to do the whole problem, at least getting something written down or getting the setup is a really good place to start. Yes?
So I got like a different value for the end number, the like you got negative 0.22,
Mm-hmm.
I got like a negative 0.17. But does that matter since you put the is less than 0? Do I have to have that value?
I don't know. So we can check this, and this is where the sample responses are good, because sometimes you'll see like a mistake that maybe on the rubric you have a hard time grading for yourself, but then if you can find someone in a sample response who did something similar to what you did, you can see how it would be graded. I'm not sure because this doesn't actually get a point. So the part that is important is that it is less than 0. So honestly, I'm not sure about that. Yeah. Did I have another question still? No? Yes.
For the using, I did f of 5 instead of g of 5.
Right, so the difference would be negative, but you didn't write that. You just said f of 5 is greater than g of 5.
I still did the work. I didn't put it g of 5.
You didn't write it like that. So when the teachers come in to grade the AP exams, they don't just have the one-page rubric. They have like a whole packet for their one problem. They don't grade everyone's. They grade like one FRQ and that's all they grade. And they don't have the one page. They have like a whole thing. So I think the rubric is supposed to be like the most representative of like the typical way to do the problem. I think things that are mathematically accurate that still say the same thing but maybe in a different line of thinking should still get the same points, if that makes sense. So I would think that you would get the point. I can't say for sure. This is where my like inexperience kind of works against me, but I would think that you'd be okay with that. Just because I do know that there's lots of different ways to get to the answer sometimes, lots of different ways to write it. They don't always have all those written down. Yeah.
Can you explain how you do D?
Yes. So for part D, we have to consider the 50 pounds from the beginning of the problem. So 50 pounds of bananas that are on the display. And then we're taking into account that for 8 hours, the bananas were being removed from the display using f of t. And then we have to take into account that after 3 hours, they started adding bananas to the display. Right? And again, if you wanted to make sure that you don't write something incorrectly and then lose the point, I would use, for this one, the f of t, and for this one, the g of t.
Why did you put 3 to it again?
Because they said that g of t, that started happening. They started replacing the bananas on display after the store had been open for 3 hours.
Okay.
All right, so what I want you to do next is go ahead and grab your sample response packet, and we're going to turn to page 4. So what I did, if you have looked at the sample responses online ever, they always give you 3 sample responses. They give you one from a student who got all the points, one from a student who got 6 out of 9 points, and one from a student who got 3 out of 9. So I did not include in this packet, I did not include the student who got a perfect score. I did include student B, which is the student who would have gotten a 6 out of 9 as their score, and I included student C, who is the one who would have gotten 3 out of 9. So what I would like for you to do is to look at these pages and compare these with the rubric and make a guess as to what you think their score should have been, and I want you to actually write it on this page. And then once we've made our predictions, we will flip and we will look at what their actual point allotments were and the reasoning behind that and see if we understand how the rubric works. Okay? So go ahead and take a moment, look over their answers, give them a score. Page 4 in the sample response packet, and looking at student B first. So you should have your rubric from your rubric packet, right? And then you can compare it. What page was it? Page 2, I think? If you flip to page 6, on this page it has exactly what score they did receive and why. Okay? So go ahead and read through that. The reason that going through this type of scoring is good is that you start to learn things. For instance, the way that the grading works, if you don't get the setup point, then often you are not eligible to get the rest of the points. Okay, that's something that you'll learn as you start to read why a student response was scored the way that it was. They'll say, they got this wrong, therefore they were not eligible for the rest, so we didn't even look at it. Does that make sense? So go ahead and read through this, see how accurate your scoring was. All right, so I think this actually answered a few of the questions we had. So one thing that I'm seeing when I looked into this is that there was a point where they rounded to 2 decimal places and they didn't get marked down. Why did they not get marked down? It was an intermediate step. It helped them think about their conclusion, but wasn't part of the actual answer. I think your question is answered because their F of 5 was incorrect and it did take that point off. So if your difference was different than what it should have been, then that would have lost you the point. Okay. Are there any questions that you have that reading this brought up? Okay, so the reason I gave you a packet that has so many questions in it is because even if I'm not here to kind of guide you through the problems, you can still take yourself through this process with some of the other FRQ questions. And what I did when I was trying to pick which FRQs to bring before you today is I looked at like all the ones from 2012 up to 2018 to see which FRQs would be most representative of that topic, and maybe have a part A, B, C, or D that asks something that students typically struggle with. Okay, so I was really deliberate to choose which FRQs from which year so they would be the most beneficial. Okay, what other FRQ would you guys like to go over? Area and sum? Or area and volume? We can do that one. Area and volume? Okay, so go ahead and in your blank FRQ packet, we're going to flip to the area and volume question. So that's at the end. This is also a number 2 question, which means that this one is calculator active. Okay. So first, part A says find the volume of the solid generated when R is rotated about the horizontal line. Do you guys remember what formula we use? Not 2 pi r. Pi r squared. Okay, how do you figure out what your R is? You're going to do an integral, yep. So your integral is going to have pi r squared, and then R is something specific from the problem.
It's the area of like the shaded.
It is, yeah, and this is, we have the disk method and the washer method.
It's disk.
Because there's no space.
There's no space, so when you think about this curve being rotated around this horizontal line, there will not be white space in between,
No, but it's around the horizontal line.
and it's around a horizontal line. So to figure out the R value, we're going to do top minus bottom. Top line minus bottom line, that's your R. And you're doing an integral. Okay, do you have an idea of what you're going to write for that one? Top minus bottom. Okay. Yes?
Yeah.
Say it again? Oh, yeah. No, you're right. You're right. Sorry, I was thinking it was rotated. I was like, they still look so confused. Okay, so the R is still calculated the same way, but it's not the disk method. I'm sorry, guys. This is...
Now it's washer because
it's washer because we're rotating around this line. I'm sorry, I wasn't reading it closely. I was reading it as it was rotated around this horizontal line instead of reading the actual part A. All right, so it's washer method, which means you're going to have 2 different R's, right? So this is where we have pi big R squared minus pi little r squared. Okay, and our big R, so our R's are still calculated by top minus bottom. And how do we differentiate between like the bigger R versus the little r?
you take the distance.
Yeah, the further distance and then the shorter distance. Yeah, good job. Okay, sorry, is it clear as mud now? Did I confuse that? Okay. All right. Region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis. So for me, whenever I see perpendicular to the x-axis, I like that because it means everything gets to be in terms of x. When you do this, because remember, some of these can be in terms of y. So when you're doing perpendicular cross-sections, x-axis is good, it means x. Isosceles right triangle, what does that mean? That's good, you like memorized that. So isosceles, I don't have it memorized like that, but I like that. Isosceles triangles are ones where two sides are the same. Isosceles right triangle means that you have a right angle, right? Okay, so what they're telling you, basically, this is your isosceles triangle. They're saying, like, this is side A, this is side A, like that. It means they're telling you, basically, and they said that the leg is in R. The legs of the isosceles right triangle are what are considered to be the same. They are telling you in a roundabout way that the base and the height are the same measurement. Does that make sense? So when you're finding the formulas that my students looked at, we had S's in there. I don't know if you guys had S's or not. But you would have base times height, which would end up being the exact same measurement. Okay? And then how do you figure out what that part is? For us, we did S or B at your school, whatever letter it happened to be. How do you figure out what it is for the specific problem? So you're doing, it's kind of like finding the R in the revolution problems. You're doing the exact same thing where you're taking the two different curves into account. So at our school, we called it S, but it's whatever letter you use in the formula to represent the two different curves. And so again, it's going to be top minus bottom. Okay, so that's going to help you figure out. So your base, the base of the triangle would be top minus bottom. Since the height is exactly the same measurement, you're going to have what she said, which is 1/2 of that top minus bottom squared. Okay. So because we have the area of a triangle is 1/2 base times height. And your base and your height are the same. Okay. So 1/2 base times height, base and height are the same. That's going to be calculated by doing top minus bottom. Okay. This part C is I don't like these questions, but they seem to happen fairly often. So it says a vertical line x equals k divides R into two regions with equal areas. So you're picturing, like, I don't know, maybe k is right here-ish. And you're saying that this area and this area are the same. That might have been a terrible halfway. You get the idea. All right, so write, but don't solve, an equation involving integral expressions. All right, so with that one, give your best. I can't really give you a hint at that one without just telling you what it is. So do your best to try to figure that one out, and then we'll go over it. Okay, so go ahead and try this one. Again, using your calculator, so don't do stuff by hand, just plugging it into the calculator. Math 9 for integrals. I don't think you need to do any derivatives. Again. Okay, so answers. First thing you needed to do was set f of x equal to 4. Go ahead and get your rubric out. If you don't have your rubrics out yet, go ahead and get those out. Now, sometimes I see that they give points for showing this, that you considered it, but anything you do on a calculator, you really should have written down on your paper. So the first thing we did was to find our bounds, is we graphed the curve and we graphed that horizontal line at 4, and we found the intersection, that it was 0 and 2.3, and that really should be written down on your paper if you did it, okay? Sometimes I see them giving points for stuff like that, sometimes not, but definitely have it written down just in case, okay? So that means that my bounds are from 0 to 2.3. I have pi of big R squared plus little r squared, so this is top minus bottom, so 4 minus -2 for my outer radius, the curve minus -2 for my inner radius. Does that make sense? All right, and then 98.868 is what you should have gotten. And 98.867 is what I was talking about with the truncated rounding. That means you didn't think about rounding up or down. You just cut off at the third decimal, and that's fine. They'll give you points for that. Okay, so 2 points for the integrand. That's talking about like the stuff that you integrated, getting the squareds on your r's and having your r's be correct and all that. When they say that they give you a point for the limits, what they mean by the limits is 0 and the 2.3. Those are the limits. Minus. Dang it. Yeah, so if that was me, I would have gotten marked down for that. I didn't type it in my calculator, though, because I have the right answer. That's a good point, though. So I should have had a minus there, and I just wasn't paying attention. If they looked at your paper and saw that, you would not be eligible for the answer point, because your integrand is wrong. Good catch. Okay. For part B, we have to do figuring out our S or B or whatever letter you call it. We're figuring out what the base of the triangle is. So we're doing top minus bottom. So this would be like the length of the base for this triangle, the length of the base for this triangle, the length of the base. And then since the base of the triangle and the height of the triangle are the same, we're going to be doing that top minus bottom squared. So this is me showing top minus bottom squared. And then since the area of a triangle is 1/2 base times height, I've got that 1/2 in the front. Okay, using the same bounds. So again, you can see they gave 2 points for the integrand and then 1 point for the answer. This one, again, I rounded it, but you could do truncated rounding. And then for the last part, part C, there's a couple different ways you could write it. 0 to k of your integral should be 1/2 of the whole thing. Or if you look at your rubric, you can see that they said 0 to k should be k to 2.3. That's just showing like the left half and the right half equal the same thing. As long as you're being clear that it's half, then you're good. Okay.
Oh, that's why you have the 1/2.
Because I'm saying this is the whole and that's 1/2 of the whole thing. So the instruction said to find a vertical line. So when they're saying find a vertical line, they're basically saying find a bound that would cut the picture in half. So I'm saying 0 to k would equal half of the whole thing. Okay. Or you could say 0 to k equals, and then don't put the 1/2 and put k to 2.3. And then that would be you saying the left half and the right half are the same.
Do you have to write two equations or just one?
It says, I think it says to write an equation in the prompt. An equation. It says write an equation. So you do have to have an equal sign and stuff on each side. You could say,
What does the K stand for?
the K stands for some line that's cutting the picture in half.
Okay.
So it would be your new boundary. If this is from 0 to 2.3, then that would be some decimal number in between 0 and 2.3.
And that's why you say, okay, makes sense.
Okay. All right. Yes?
These are the placing of the square in B. Do you put it inside the integral, or so are you squaring the 4 minus?
So
f
when you start typing the integral, it automatically puts a parenthesis. I put an extra.
Yeah, I did as well. I'm still getting a weird time.
So, okay, so if we were to type that, we would have, or let me do the 1/2 first. 0 to 2.3. So I have the parenthesis already. I'm going to type another one. And then I have 4 minus parenthesis x to the 4th minus 2.3 x to the 3rd plus 4. I end the parenthesis for that group, and then I end the parenthesis to show that I did top minus bottom, and then I square it. And then this parenthesis is end parenthesis for the whole integral.
I don't know why it's angry. It doesn't like whatever I did.
I can come look at it in a second, okay?
Oh, there's a random square hanging out like a couple lines up.
There you go. That might be it.
Yep, there
Okay,
it is.
perfect. All right, so let's go ahead and look at the sample responses. So this is page 22 of your sample response packet. I do want you to look at person B for sure. I want you to look also at person C, specifically their part C. I do want you to grade that and see if you agree with it or not, that they should get full points, okay? So don't look at the actual points they did get, but I do want you to look at person C, their part C, because I think the way they wrote it is interesting, and see what grade you would give them, and then we'll check and we'll see what grade they actually got. Okay, so take a moment and look at those. All right, so if we look at person B for their part A, you can see that the outer R, the big R, they did that part correctly. But on this one, they forgot to minus the -2. They forgot to do top minus bottom. So if you look at the scoring, the integral or integrand part was worth 2 points, and they got 1 of those 2 points. Okay, so they got the point because they had the outer radius, they had that 6 squared correct. They did not get the second point because they didn't have the minus negative 2. The second point they got for that problem was having the limits from 0 to 2.3. All right, and then they were not eligible for the answer point because their integrand was wrong. So of the 4 points, they only got 2. Okay. For part B, if you look at this one, they had that formula correct. They didn't type it in correctly. So they did not get that answer point. Okay. So this is why it is important to practice, like if your teacher ever does typing stuff in, you should be typing in with them to make sure that you know how to type all those parentheses and get everything right so you can get that answer point. And then they did part C perfectly. I liked, if you look at part C for person C, what did you guys think as far as how many points they should get?
That's just like the brain part, right?
Mm-hmm. How about their, so what did you think? I didn't even look at the rest of theirs, but how did you feel about part C?
So it didn't guarantee that it would be exactly half.
Yes, and that was their problem. So they did not get points for this because that doesn't say anything about it being half.
K could be any line.
K could be anything. Okay, so we know what they meant, but mathematically speaking, that doesn't earn you anything. Okay, so you specifically have to have something that is clearly saying it is half. Okay, yes.
So when you do, if you do 0 to K, do you have to put 1/2 in front?
You have to, there's got to be something somewhere to make sure that you know that they're equal.
Could you do-
So you could say these two equal each other,
Yeah.
or you could say that like this is half of that, or this is half of that. You have to do something, because right here, this could be 0 to 0.1 and then 0.1 to 2.3, right? You have to do something to say that K is halfway. Or not that K is halfway, but that K is splitting it in half. Yeah, you have to switch up. Yeah. Okay. What question should we do next? Say it again? The Riemann sums? Yeah, we can do that. Does that sound good to you guys?
Yeah.
Okay, so Riemann sums. Let's go ahead and look at question 10 and 12 and figure out which one we'd rather do. So 10 has a table, 12 also has a table. Water in a tub, coffee maker. Coffee maker, okay. No snacks, so we're going to think about coffee. Bananas and coffee, right? No calculator on this one. This one's a number 3. Yeah. All right, let me find it. Yeah. Okay. So, part A, we're approximating the derivative of 3.5, but we don't have an equation to find the derivative of. Do you guys remember how we approximate a derivative if you don't have an equation? Yeah, you do your average rate of change, so like your slope formula, and you just say, this is the best I can do. I'm going to say that it's an instantaneous rate of change even though it's average. One mistake I see all the time with students is they do the x's over the y's instead of the y's over the x's because the table's set up like that, so be careful to flip that, okay? Your y's are the second part of the table, not the top. Okay, so make sure you're doing your slope the correct way. Units of measure, make sure you include your units. They're in the table. So those are usually not too bad. Okay, part B. Part B is going to have you use something specific. A specific theorem. Anyone know what it is? Mean value theorem. Okay, mean value theorem. So we know that it's the mean value theorem and not, is it the intermediate value theorem, because it's talking about slope, right? So that means that you have to find your slopes at these two different places. And then use that, this is where you say, because this is continuous, blah, 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 on this interval, there is some C such that blah, 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 that whole, like you have those whole formal sentences. Okay, so I'll let you guys get as close to that idea as you can and then we'll correct it. Use a midpoint sum. What does it mean when it says midpoint sum? not left, not right. Use the middle. It says 3 subintervals of equal length. Okay, so we're taking, if the whole interval is from 0 to 6, then how wide are the intervals we're using going to be? 2. So it says from 0 to 2, 2 to 4, 4 to 6, and we're going to be using the midpoints. So we're using 1, 3, and 5, basically, those y coordinates, okay? To approximate the value. What does that 1/6 in the front mean? Yeah. Oh, that's fine. I thought you were answering. I was like, he is on it, but he's just like. Do you go to school? Are you part of any of the people here? You know any of the people here? Yes, marvelous. Okay, so you can update him. Yes. Average. Yes. So this 1/6 in the front is telling you that this is the average value of the integral. So remember that's 1 over the b minus a average value. So that's going to take into, you're going to have to think about that when you explain the meaning, okay, of all the area underneath the integral. Okay. And then for part D, the amount of coffee in the cup is modeled by this equation. Using the model, find the rate at which the amount of coffee in the cup is changing. So what are they asking you to do in part D? Derivative. Because they're saying rate of change. Okay? All right, go ahead and take some time. Work on that one. All right. So, there we go. Doing just your basic slope formula, right? So I got 1.6 ounces per minute. And if you have your rubric out, you do have to have that approximation, and you have to have your units written. For the mean value theorem, calculated what the slope was between those. So you end up getting that the slope between that point at 2 and that point at 4 is the slope of 2. So I specified that the function that they gave us, or the table they gave us representing C of t, is continuous and differentiable on the interval from 2 to 4. And so by the mean value theorem, there's some value on 2, 4 such that C prime of that value is 2. I wrote that very formally. I don't think you have to write it quite so formal, but yeah.
And how did you do C of 4 and C of 2? Because those are just like...
Those are the values they gave you, the interval they gave you. So we're saying if the average slope on that interval is 2, then at some point on that interval there has to be an instantaneous slope of 2 as well. That's what the mean value theorem says. All right, for part C, 1/6 of the integral from 0 to 6 of C of t dt, and then we're using those midpoint. So width of 2, midpoint of 5.3, width of 2, midpoint of 11.2, width of 2, midpoint of 13.8. You can see I did lots of decimal work off to the side to get my answer over there. Okay, and then for your interpretation, it's the average amount of coffee in the cup from the time t is 0 to t is 6 is 10.1 ounces. So they're expecting to see the word average in there because of that 1/6 in the front. All right, and then for part D, we have to find the derivative first. And since it has, I've got 0 for the first derivative, and then since it's e, we're doing, with an exponent, we're doing the chain rule. And then we're plugging in a 5. And so you can see I kind of simplified using my exponential rules there. Okay. Now, one thing I know of is that when you are doing problems where you're plugging in numbers to get answers, you are supposed to be able to do the first step where you plug in your evaluation, and then technically you can stop. You don't have to continue with your calculations, which means that in theory you could have written this and stopped there. Not necessarily have to do all those decimals and get to the 10.1, or you could stop here, which I think is why they have those answers written. So that's something to keep in mind. If you want to do the calculations off to the side, you could do that, and then if you don't feel comfortable with them, you could put like a big slash through it. Technically, if there's a slash, they're not supposed to grade it. All right, so that's something to keep in mind as well. Same thing for part D. You could just plug in the 5. You don't necessarily have to simplify that. Also, the negative 16 times negative 0.4, you technically don't have to simplify that either.
So you could literally just have
Yes.
that first thing.
Yes. Because you found it, you just haven't, you know what I
You
mean?
haven't
Like it's
typed it.
there, right? It's there. So that's something to keep in mind. Another thing that I've heard from teachers to do or versus not do when you're working on FRQs is you should not be boxing your answers because if you box it, then they have to take that as your final answer. If you just write a final answer on the page, then they can kind of look around the page and grade everything. Does that make sense? Okay. If you have two, let's say you're not sure how to do the problem and you do it two completely different ways, if you leave both of those and don't cross one out, then what they do is they score them separately and then they average the scores. Okay, so they give you like middle. Yeah.
Can you do the chain rule on D, like,
Yeah, write it out.
yeah.
So for the 16 in the front would have a derivative of 0, right? And then what I did is I kept this exactly the same, negative 16e to the negative 0.4t. And then the exponent has the derivative of just that coefficient, so I multiplied by the negative 0.4. And so that's why on the page, on the rubric, they have 16 times negative 0.4, because they're taking this on the end and they're multiplying it by that negative 16 right there. And that's where the 6.4 came from. Okay.
And you just plug everything in there.
Mm-hmm. Okay. All right, so on your sample response packet, page 16 is where they have the student responses. I think that this one has some interesting questions that are kind of nice to get answered. For instance, this student, instead of saying C of t, they're using like f of x right here, kind of. So I think that they address that in the reason for their getting the different points they got. So I think that this one just has some interesting things that kind of help you figure out how they count points and grade down or not grade down. Okay, so go ahead and look at those. So one of the things that I thought was interesting about this, that was just good clarification, is they said for student B, the use of F instead of C was ignored. I kind of liked that. It was like, I knew what you meant, so they weren't marked down for that specifically. Okay, they were marked down just because their work was wrong, but they didn't get marked down for using F instead. Same thing for the mean value theorem. It said that they ignored that use of F there, even though technically it should have been C, because mathematically speaking, they did that right. Does that make sense? Okay, so I thought that was good stuff to notice. They did get marked down on this one in their interpretation because they didn't say, they did say the word average.
They said per hour instead of
Per hour instead, okay.
and it's not like per.
Yeah, right. Right. All right. I don't think that. Oh, if you look at student C, their answer for part D, they did have they had the right answer to start with. They multiplied this wrong. So be careful to watch out for stuff like that. They could have had the point, but they multiplied that wrong. So if you're not feeling real confident about I took my time in my computations by hand and I did a good job, exit out and just leave the unsimplified version, okay? All right. Do we want to do another FRQ? We could start one at least, get some hints, yeah.
Could we do like a velocity acceleration?
Yeah. Okay, so if we look, we probably have a couple options. So we've got this one, and we've got this one. I think, so this one is calculator active. I think the 2017 one is not. Yeah, so we have a PVA problem that is calculator active, and then we have a PVA problem you have to do by hand. Which one would you guys rather look at?
By hand.
By hand? Okay, so we're doing page 8. Yeah, as much as I hate doing it by hand. Okay. So if we look at this question, for part A, it says, when is the particle moving towards the left? How do we figure out when a particle is moving towards the left? What's negative? The velocity, okay? So they gave you the position, and you need to find the velocity, so you need to find the derivative. And, because this is particle P, so you need to find the derivative of that, and then you need to figure out when it is moving to the left, so you need to figure out when it's negative, okay? So let's think through the process of this. We have to take the derivative of an ln, do we know how to do that? 1 over all of this stuff, times the derivative of this stuff, okay? So you're going to end up with a rational function, right? And then to figure out when the particle is moving left, we're going to want to take that rational function we get when we take the derivative. We're going to want to set it equal to 0, because 0 is where it's going to switch from positive to negative, and we need to see where it's negative. Okay? So that's our process for part A.
So when the velocity is negative, which is the first derivative?
So velocity is first derivative, and we want to see when it's negative, yes. So typically we would set it equal to 0 so that we can know when it switches directions. And then figure out your positives and your negatives. Okay. We have 2 different particles technically. So for part B, you're going to keep your information from part A, because your information from part A is going to tell you, if you're making like a sign chart for that, it's going to tell you when it's moving left versus when it's moving right. And then for part B, they're asking you to take the information from the second particle, which is particle Q, and they already have the velocity for that one, and you're going to have to do the same thing. You're going to set it equal to 0, you're going to make that sign chart if you do sign charts, but you want to figure out when it's moving left versus right. That's sign charts, or when you draw the like the little line and plug in values and say plus or minus. Your teacher might not have written it that way, but it's the idea of like, sometimes people do tables or whatever. All right, and then you're going to see where they're traveling in the same direction. So where they're both going left or they're both going right. All right, part C, find the acceleration of particle Q. So what's the process for that? Derivative of the velocity at time t equals 2. So you're going to take that derivative of the velocity and evaluate it. Then this part, is the speed of the particle increasing, decreasing, or neither, and how do you know?
If the signs are the same, then it's speeding up.
Yes.
Yes.
So we take the velocity equation, we take the acceleration equation, and we evaluate them at that same number. And then if the signs are the same, it's speeding up. If the signs are not the same, it's slowing down. Okay? Now that explain your reasoning. Don't say it is the same sign or it has the same sign. You're going to say like the velocity is positive, the acceleration is positive. So you're writing this in mathematical language and not using the word it. That's one of the things with FRQs. You should never, never, never say the word it. That's not descriptive. So say the function, or the velocity equation, or the acceleration equation, or something like that. You're using that mathematical notation. Okay. Find the position of particle Q the first time it changes directions. So which equation can we use to see if it has changed directions? The velocity equation is important, right? So we are going to use both because we do want to find the actual position, right? So we're going to start with the velocity equation, and you're actually already going to have this work done because you'll have done the work for part B. Right. You'll know when it first switched directions, so that's going to give you some sort of value that you're going to use. Well, now you're going to go backwards, right? Because you're going from the velocity backwards to the position. So how do we go backwards? We do an antiderivative, so we're going to do an integral. Okay, and we have to keep in mind that the position at x equals 5, that is x equals 5 at time t equals 0. So this is one of those situations where you're going to use an integral to evaluate something, but you have an initial value to include. Okay, so it means you're going to have some sort of number plus an integral. Okay, that's your little clue there. Okay, that's the only way that we can ever possibly find an actual y-coordinate of something like this, if all they give you is an equation of the derivative. The only way you could find an actual value is if you have some sort of initial to give you that like plus c, right? Okay. All right, go ahead and work on that.